We also talked with a philosopher of science, Tomi Kokkonen from the University of Helsinki.
Maybe we could just say that why we called him again was that when we were doing science poems, we felt that we need some outside influence. We need somebody who's not an artist or designer or design theorist or art historian. We need to call someone who's working with the field of science, but in a philosophical way. So we just called to the local university and asked them, like, could you give us the contact details of some local philosopher of science? And this is how we ended up meeting him.
And it was a really fruitful discussion, which is also in the book. But maybe as a quote from that discussion, this kind of describes the content. By applying artistic perspectives to scientific processes and results, it is possible to make science more approachable and perhaps more useful for the lay people. And this is one of the characteristics that we definitely feel that designers can or are good at. Visualizing complex information, and also we believe that not only that the design tools, the ability to visualize or make something more understandable, beyond that, designer has quite a lot of power in terms of choosing what to visualize and what not to visualize. If we're talking about self-initiated projects, so we can actually have an influence on or guide people towards good decisions, or at least decisions that feel good to us, or worth doing it.
And then we are just going to show two examples from the exhibition that we curated with the 6 designers and artists who are dealing with different areas of science. This is the fashion designer Koi Kinnunen, who took part and explored physics through her clothing collection, which was called Faraday Suit. And it's basically the clothing is made of materials that partly mentally and partly in reality protect you from electromagnetic radiation. And the idea of the clothes is to kind of, when you wear them, they make you think about all the physical phenomena that are taking place around us, but we can't see. Like electromagnetic radiation. It's a big issue nowadays when people are discussing whether it affects us, whether it's a bad thing for us, or if it's scary, or if it's what it is. So the idea of the dresses was to make people think about it.
And protect themselves from it, kind of grounding. I think that piece is particularly a lot of influence from the design interactions department and from Anthony Dunn's thinking. Then this one is Miska Knobek's generative data visualization piece. It's part of the earth sciences or meteorology category, and it's called wind tracing. It's in a way like a poetry reading of the wind's movements, its direction as well as its strength or amplitude. This depicts a week of wind in Helsinki. So it's not only it should move, but now it's still. But it's almost like a pencil that draws the movement and the strength of the wind in real time. And this way, Miska likes to make this, he calls them spatio-temporal images, but kind of different presentations of space and time, something you couldn't do in one photo. Even though he does that too by cutting up several photos, but to depict to capture a moment over a longer period of time, like here, a week in Helsinki, which was a particular week for him, with some friend visiting, and he wanted to give this as a kind of greeting from Helsinki or something to remember.
And this is the last slide of our presentation, and maybe what we could say in the end is that science poems was definitely for us a project that helped us somehow to define ourselves. And even though we still don't know what we are after working on it for some time, you could call it a tool for us to find out what we are and what we want to do. How much do we have time at the moment? I'm wondering if it's... Okay.
We're thinking of doing a small reading with physicist Richard Feynman. This is a piece from the book, which is inspired by event scores in the spirit of Yoko Ono and other Fluxus artists, as well as Richard Feynman's interpretations of physical reactions that he described in an 80s, I think it was 80s BBC series, Physics is Fun to Imagine. So we're going to play small bits from his stories, and then I will read my interpretations of them as in a way like tools to actualize them in actions, and maybe use them as further tools to explore these phenomena whilst seeing and understanding them better.
Most elastic things like steel springs and so on is nothing but this electrical thing pulling back. You pull the atoms a little bit apart when you bend something, and then they try to come back together again.
They like to be next to each other. They want as many
But
partners.
rubber bands work out a different principle.
The guys that are at the surface,
They're
there's only partners on one side here, in the air on the other side, so
Okay,
they're
let's
trying
watch
to get
this
in.
first.
And you can imagine.
It started working.
3:50. Yeah.
3:15.
Yeah. Yeah.
This picture of atoms is a beautiful one, that you can keep looking at all kinds of things this way. You see a little drop of water, a tiny drop. And the atoms attract each other. They like to be next to each other. They want as many partners as they can get. Now, the guys that are at the surface,
No. I tried to make it bigger. I pushed the wrong button. This is this one. Sorry.
guys that are at the surface have only partners on one side here, in the air on the other side, so they're trying to get in. And you can imagine this team of people, these teeming people, all moving very fast, all trying to have as many partners as possible. And the guys at the edge are very unhappy and nervous, and they keep pounding in, trying to get in, and that makes it a tight ball instead of a flat. And that's what, surface tension, the way when you realize, when you see how sometimes a water drop sits like this on a table, then you start to imagine why it sits like that, because everybody's trying to get into the water. And at the same time, while all this is happening, there are these atoms that are leaving the surface, and the water drop is slowly disappearing. I find myself...
And the water drop piece goes like this. Take a mannerism from an atom in a drop of water. Gather a group of people in the same room for an hour. Remain surrounded by a person on each side of you at all times. And the next one is rubber band piece.
Most elastic things like steel springs and so on is nothing but this electrical thing pulling back. You pull the atoms a little bit apart when you bend something, and then they try to come back together again. But rubber bands work out a different principle. There's some long molecules like chains, and other little ones that are shaking all the time, that are bombarding them, these chains. And the chains are all kind of kinky and knocked about and shake. When you pull open the rubber band, the strings get straighter. But these strings are being bombarded on the side by these other atoms trying to shorten them by kinking them. So it pulls back. It's trying to pull back, and it's pulling back only because of the heat. So if you heat a rubber band, it'll pull more strongly. For instance, if you hang a weight with a rubber band and put a little match to it, it's kind of fun to watch it rise, the way it heats more. And there's another thing you can check that this idea is right, that it's heat that drives a rubber band. If you pull the band out, just like when we push the piston in the gas, if you pull the band out, this tightening string hitting those molecules makes them move faster, and so it's warmer. And if you take the band and let it in, then the molecules hitting the strings, which sort of give as the thing hits, they give in to the soft like, and they lose energy when they hit these retiring strings. So it cools. And there is a little way you can do this. You're not very sensitive. It's a small effect. And if you take a fairly wide rubber band and put it between your lips and pull it out, you'll certainly notice it's hotter. And if you then hold it out and let it in, you'll notice it's cooler. At least you'll notice a certain difference in what happens when you expand it, when you contract it. And I've always found rubber bands fascinating to think that when they're sitting on an old package of papers for a long time, holding those papers together, it's done by a perpetual pounding of the atoms against these chains to hold it, trying to kink them year after year. Well, rubber bands don't last that long, but anyhow, for a long time, trying to hold this whole thing together. The world is a dynamic mess of jiggling things if you look at it right. And if you magnify it, you can hardly see anything anymore because everything's jiggling and they're all in patterns and they're all lots of little balls. And it's lucky that we have such a large-scale view of everything that we can see them as things without having to worry about all these little atoms all the time.
Wear a rubber band on your waist, eat a sandwich, think about the atoms that are pounding on your stomach.
A mirror, and let's say you part your hair on the right side. Then you look in the mirror and the image has got its hair part on the left side. So the image is left to right mixed up. It's not top and bottom mixed up because the top of the head of the image is up there at the top and the bottom of the feet is at the bottom. And the question is, how does a mirror know to get the left and right mixed up and not the up and down? You get a better idea of the problem if you think of lying down and looking at the mirror. All right, your hair is still on the left side, and now the left and right was the up and down, whereas the up and down, which look okay, was the right and left before it, and the mirror somehow figured out what you're going to do when you're looking at it. So to describe in a sort of symmetrical way what a mirror does, that it doesn't look lopsided, that it takes left and mixes it up with right, and it doesn't do the same with up and down. And after a lot of fiddling, I knew we worked out the answer to that one. You see, if you wave this hand, then the hand in the mirror that waves is right opposite it. The hand on the east is the hand on the east, and the hand on the west is the hand on the west, and the head that's up is up, and the feet that are down are down. Everything's really all right. But what's wrong is if this is north, your nose is to the north of the back of your head, but in the image, the nose is to the south of the back of the head. So what happens really in the image is neither the right nor left mixed up with the top and bottom, but the front and back have been reversed. You see, that which is the nose on the thing is on the wrong side of the head, if you want to. All right? Now, ordinarily, when we think of the image, we think of it as another person. And we think of the normal way that a person would get into that condition over there. It's a psychological thing. We don't think of the idea that the person has been squashed and pushed backwards, forwards with his nose and his head, because that's not what ordinarily happens to people. A person gets to look like he looks in the mirror by walking around and facing you. And because people, when they walk around, don't...
Mirror all photographs of yourself on Photoshop. Destroy the originals. There's one more in the book, but I guess we're kind of over time already. So we could spare some time for questions. And this was just to demonstrate an experience of science.